Right now, somewhere near you, there is fire. Maybe it's a stove burner. Maybe it's a lighter in someone's pocket. Maybe it's just a candle on a shelf, sitting there, doing nothing, waiting. You barely notice it. Fire is furniture to you. It's background noise. You've never once been afraid of it the way your body was built to be. But somewhere, hundreds of thousands of years ago, one of your ancestors looked at fire for the very first time, and nothing about that moment was ordinary. The real answer to what happened is far stranger than they discovered it. Because fire didn't arrive as a discovery. It arrived as a threat that refused to stay a threat. Picture the scene. Not a campfire. Not a controlled flame in a stone circle. A wildfire, cracking across dry grassland, driven by wind, swallowing trees whole. Every animal for miles is running the other way. Every animal, that is, except one strange, upright, oddly persistent primate. Why would anything run toward that? It didn't. Not exactly. Anthropologists studying early hominin behavior believe the relationship with fire almost certainly began by accident, through what researchers call fire scavenging. After a wildfire swept through, it left behind something valuable: charred animals too injured or slow to escape, roasted tubers baked in the scorched earth. Suddenly, food that used to require hours of chewing became soft, warm, and shockingly easy to eat. Your ancestors weren't lighting fires yet. They were following them, walking into the smoking, blackened aftermath other animals were too afraid to enter, and eating what the flames left behind. That single behavior, scavenging burned landscapes instead of avoiding them, may be one of the strangest pivot points in human history. It meant something inside this species was willing to tolerate fear long enough to get close to something everything else avoided. Anthropologist Richard Wrangham has spent decades studying what happened next, and his research points to a transformation almost too large to comprehend. Wrangham's cooking hypothesis argues that once early humans began regularly eating food altered by fire, their entire biology started to shift. Cooked food is dramatically easier to digest than raw food. It delivers more usable calories for the same amount of chewing and stomach work. That extra energy had to go somewhere. Wrangham argues it went to the brain, an organ that is metabolically expensive, burning roughly 20% of your body's total energy, despite being a small fraction of your body weight. A raw food diet, in his view, could never have powered the brain size modern humans eventually developed. Fire-touched food could. In other words, the first time a human ancestor tasted something cooked by an accidental fire may have quietly set in motion the biological chain reaction that eventually produced a brain capable of asking questions like the one you're asking right now. But scavenging burned meat is one thing. Keeping fire alive on purpose is something else entirely, and that leap took an almost unimaginable length of time. Archaeological evidence for controlled fire use, meaning fire that was tended, fed, and kept burning, rather than simply exploited after the fact, becomes much clearer around 1 million years ago. A site called Wonderwork Cave in South Africa contains burned bone fragments and ash residue that researchers, including archaeologist Francesco Berna, have dated to roughly this period, suggesting hominins were bringing fire into sheltered spaces and maintaining it there. Imagine what that actually required. No matches, no lighters, no flint specifically designed for the job yet. Keeping a flame alive meant constant attention, someone watching it, feeding it, protecting it from wind and rain, day after day, for it to still be burning weeks or months later. Losing it might mean waiting an unknown length of time for the next lightning strike or wildfire to hand you another chance. This is where fire stopped being something that happened to early humans and became something they were responsible for. And responsibility changes everything about a species. A tended fire needs someone present. It needs turns. It needs coordination between individuals who might otherwise ignore each other entirely. Some researchers argue that the discipline required to maintain a fire, night after night, may have quietly shaped early social structure itself, creating a reason for groups to gather in one place, at one time, facing one shared point of light. Think about what that circle would have felt like. Cold darkness stretching in every direction, filled with predators whose eyes work far better at night than yours ever will. And in the middle of that darkness, a small, contained piece of the very thing that used to mean total destruction, now sitting quietly, generating warmth instead of consuming everything nearby. That contradiction is almost impossible to oversay,